Hello everyone, I welcome you all to Startup Academy, your online gateway to success in ISS exam. This academy is exclusively for ISS exam and we are focusing on ISS 2026. As we discussed yesterday, the cutoff has been growing higher and higher with the coming time and it has been 55%, which means 55% marks has been scored the last selected candidate and below them everyone else was rejected. So it is important for us to focus now and to leave all the distractions behind in order to be an ISS officer. As it is, there are very limited number of seats in the examination. So we have covered the topic econometrics. I want you all to keep on revising those topics and keep on watching that lecture videos. If you have any doubt, you can ask us on our WhatsApp channel or in the comment section. And now you can start. We have started with sampling techniques, in which majorly we have covered two samples: simple random sampling with replacement and without replacement, and stratified random sampling. Systematic random sampling has also been completed. We have till now done linear systematic sampling, which means that we were taking samples from a linear population. Now we can take a sample from a circular population. So the second type of systematic sampling is circular systematic sampling, which we are going to discuss today. Circular systematic sampling. So it is equivalent to linear systematic sampling. The only thing is we can re select the sample from while going in a circular motion. Let us take a population of 5, 11, 12, 13, 19, 25, 28, and 31. This is a circular systematic sampling population where the number of population size is 8 and the sample size which we have to draw, let us consider is 3. So our interval of sampling should be 8 upon 3, which is equals to 2.67. So we can take it approximately equal to 3. Now the samples which we can draw. Suppose I'm starting from this. Randomly I'm selecting first sample. Randomly I'm selecting R1 is equals to 5. So my sample would be 3 with a gap of 3. So first one is 5, then the second one is 1, 2, 3, 13, 5, 13, then 1, 2, 3, 28. So our sample would be 5, 13, and 28. So this was similar to linear systematic sampling, where the endpoint is 31 of the population. We have considered the sample within that. Suppose if my R1 now is 19. So my sample would be, first one is 19, then 1, 2, 3, 31, then 1, 2, 3, 12. Now we are going back again the track again from the starting of the sample, so as to complete our total number of samples. So it will be 9, 31, and 12. This is circular systematic sampling, in which we can we can start from all over again in order to complete our number of samples condition. So let us move forward with the derivation. So notations are as follows. Yij. This is the jth unit of ith column in the population. We have done the layout of systematic population, so we selected ith column, and in that jth unit is Yij. So we can write y bar I dot as 1 upon m summation j goes from 1 to m Yij for all I goes from 1 to n. We have changed m and n here. You can take k and n as you wish, but I have changed the denotions here. So population mean, which is y bar, is nothing but 1 upon n summation I goes from 1 to n y bar I dot. Now opening y bar I dot, we get 1 upon n summation I goes from 1 to n summation j goes from 1 to m Yij upon capital M. So this can be written as 1 upon mn summation I goes from 1 to n summation j goes from 1 to m Yij. This is the formula for population mean. Now, if we talk about small Yij, this is the jth unit of ith column in the sample. Then y bar I dot is 1 upon m summation j goes from 1 to m Yij, where again I goes from 1 to small n. Then y bar, which is sample mean, can be written as 1 upon n summation I goes from 1 to n y bar I dot. This can, when we open y bar I dot, we'll get 1 upon n summation I goes from 1 to n 1 upon m summation j goes from 1 to n Yij, and this can be written as 1 upon m n summation I goes from 1 to m 1 to n summation j goes from 1 to m Yij. This is the formula for sample mean of circular. So we'll write it as CL for derivation. Now we'll check for unbiasedness. Unbiasedness, we will find the estimation of y bar CL. So if we find the estimation of y bar CL, we can write it as estimation of 1 upon m 1 upon m into n summation I goes from 1 to n summation j goes from 1 to m Yij. Now this can be taken outside. 1 upon m n summation I goes from 1 to n summation j goes from 1 to m estimation of Yij. Now estimation of Yij can be written as the probability of selecting Yij is 1 upon m into n, and then summation I and j goes from 1 to n and capital N and capital M respectively yij. So I'm writing it directly. 1 upon m n summation I goes from 1 to m n summation j goes from 1 to m. Now we can take here as ij, I dash and j dash. So we can write it as 1 upon capital M into capital N. Summation I dash goes from 1 to capital N. Summation J dash goes from 1 to capital M, capital yi dash by j dash. So here summation of n and m will get cancelled with the denominator because small I and small m is nothing over there. So we are left with 1 upon m n summation I dash goes from 1 to n summation j dash goes from 1 to m y I dash j dash, which is nothing but the formula for our population means. Hence we can say that population mean sorry sample mean is an unbiased estimator of population mean. Now the second step is to find the variance. So variance, if we have to calculate the variance of y bar plus y bar circular sampling, we can take it as capital N minus small n upon n into SB square. Here SB square is the variance in between the samples. We have done within the sample and now this is in between the sample, and its formula is 1 upon capital N minus 1 summation I goes from 1 to n y bar I dot minus capital Y bar whole square. This is the formula. Now we know that S square, capital S square is nothing but 1 upon nm, which is the total population, minus 1 into summation I goes from 1 to n, summation j goes from 1 to m, yij minus y bar whole square. This is the formula for S square. Now from here we can write nm minus 1 into S square is equals to summation I goes from 1 to n, summation j goes from 1 to m, yij. Now we can add and subtract y bar I dot. We'll subtract here and we'll add here, and this will be also minus. So we have formed these two. So we can write it as nm minus 1 into S square is equals to summation I goes from 1 to n, summation j goes from 1 to m. First of all, a square yij minus y bar I dot whole square plus y bar I dot minus y bar whole square plus 2 yij minus y bar I dot into y bar I dot minus y bar. This is the formula. If we take summation inside, then we will get summation I goes from 1 to n, summation j goes from 1 to m, yij minus y bar I dot whole square plus summation I goes from 1 to n, summation j goes from 1 to m, y bar I dot minus y bar whole square. Now this, if we take summation over here, this will become mean deviation, which is always equals to 0. Suppose I am taking uh, summation I goes from 1 to n, y bar I dot minus y bar. This will be equal to 0. So we are not writing that. Now here yij and y bar I dot. We can this is the formula for. Okay, let us substitute first. This one is the formula for SB square. Here we have done SB square. Summation I goes from 1 to n, y bar I dot minus y bar whole square, 1 upon n. So SB square will be m, because there is no j, so m will come outside, into n minus 1 SB square. And this term, we know that SW square is 1 upon n m minus 1 into summation I goes from 1 to n, summation j goes from 1 to m, yij minus y bar I dot whole square. This is the formula for SW square, which is within sample. So it will be n m minus 1 into SW square, and this will be nm minus 1 into s square. Now we have to find, for the formula for variance, we have to find SB square. So m n minus 1 SB square is equals to n m minus 1 into s square minus n m minus 1 into SW square. Now we have to find, we'll divide whole equation by m into n minus 1. So this will be n m minus 1 upon m into n minus 1 s square minus n m minus 1 upon m n minus 1 SW square. So our formula for variance was variance of y bar circular sampling is nothing but n minus n upon n into n m minus 1 upon m n minus 1 s square minus n m minus 1 into m n minus 1 SW square. This is the formula for variance of y bar CL. Now if we want to calculate, or we can simply write it as n minus n upon n SB square. So if we calculate the unbiased estimator of variance of y bar CL, it will be variance of y bar CL cap is nothing but n minus n upon n into small s b square. We can find it like that: estimation of variance of y bar CL is nothing but n minus n upon n estimation of SB square, which is nothing but n minus n upon n capital SB square. And hence we can say that n minus n upon n SB square, or which is equals to variance of y bar circular sampling, is an unbiased estimator of variance of y bar circular sampling cap. So this completes the topic of our circular sampling. I hope it wasn't much of it wasn't much difficult, I guess. I hope you got all that we have done in the class today. And if you still have any doubts, you can ask in the comment section or WhatsApp channel. Hard and with consistency, so that we'll be able to achieve our goal of 2026, which is to become an ISS officer. So keep on watching the lecture videos regularly. All the best. Thank you.